Hello, my dear students. Welcome back to my class. In the series of learning data structures through C, in the previous video, we have discussed about the implementation of one of the stack application, that is conversion of infix to postfix and evaluation of postfix expression. Well, in today's video, we have to continue with few more topics of data structures. So we will be discussing about Q data structure. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Q data structure. So what is this Q data structure? So we have seen stack data structure. So in the stack data structure, we have seen how the data items are inserted into the stack and how the data items are removed from the stack. So we call that as push and pop operation. Insertion, push operation, and deletion, pop operation. And both these operations takes place at one end, only one end. That is from the top end. So we only have one pointer, which is top pointer, which takes care of both the operations, both insertion as well as deletion. But with respect to Q data structure, it is quite different. The name itself tells you Q. So you just stand in a queue. When you stand in a queue, just imagine you are standing in a queue, you are entering from the rear end. You enter from the rear end and you start entering and you stand in the first position. Right? So you enter from one end. And here, say just imagine you have a counter, ticket counter. You enter from the rear end. You enter from the rear end. When we enter from the rear end, do we stand there itself? No. We move forward and come to the first position. Right. So, when I stand here to the first position, the next person who entered from the same rear end has to stand next to this. It goes on like this, next. And when the counter is filled, then no more entries will be done. Then as the ticket counter you're standing, the tickets will be issued, means the person who is standing first, the front end, he will be or she will be the first to come out, right? So here from the front end we come out. So from the rear end we get in, from the front end we come out. From the rear end we get in, from the front end we come out. This is the concept of the normal queue. The same thing is applied here with queue data structure and some technical terms that what we need to remember. So here we call the different operations, like how we have push and pop with stack. We have NQ and DQ. So let us understand the definition first. So what is this queue? A queue is once again an ordered collection of items. It is also the ordered collection of items where addition of new item and removal of the existing item takes place at different ends. So in the stack we saw that insertion and deletion operation taking place at one end. But here insertion, addition of new items and the removal of existing items takes place at different end. Just now I told, we insert from the rear end and we come out from the front end. Right. So for example, I am going to insert, let me talk about some items, some input values that what we are going to put. So I just say input value I am going to store 10 into the queue. So 10 will be inserted first. Right. So 10 will be entered into the queue. So that will be entered from the rear end, it will come to the front position. Then once again I will say 20, next, 30, next, say 40, then say 50. With respect to index values, if I talk, it is 0, 1, 2, 3 and 4. So when the counter is filled, so when the queue is full, I cannot make next entry or I cannot insert one more element. So the queue is full. Now I just can't remove this. So how to remove? So this insertion I did from the rear end. How the rear end gets increased, all those things we will see with the queue values. So just imagine these things virtually. So from the rear end, we insert means it will come from the rear end and the element will be placed to the first position. Next will be to the next position. It goes on up to the last one. Say if the Q size is 5, it can store up to the size. The size equal to 5 means the Q size n minus 1. So Q size equal to 4. It can store items up to 4. Right. Then I can start deleting. So deleting means I have to remove from the front end. The first person will be the first to come out. In the sense means the first element will be the first to come out. So 10 will come out first, then 20, then 30, then 40, then 50. So insertion from one end and deletion from other end. So we call this as NQ, which is insertion. So we call this as insertion operation, and this is called as deletion operation. So NQ and DQ. NQ from the rear end and DQ from the front end. So let us understand few more features of Q data structure. So let us understand some features of Qs. So Q data structure follows FIFO principle. FIFO means first in, first out. That is, the item that is inserted at the beginning is removed first, and the items which are inserted at the last will be removed at last itself. So it is first in, first out. So you are standing in a queue. The person who enters into the queue will be the first to come out. That is first in, first out. First in, first out. This is what the ordering principle of queue. So we call this as ordering principle. So how the elements are arranged and accessed. So it is first in, first out principle. And the items are inserted from the rear end. From the rear end, the insertion process takes place. And from the front end, the deletion process takes place. So item is inserted at rear end and they are deleted, that is they are removed from front end. So the first person enters, he or she has to stand first. Then the next person, then next, and then next. If the queue is full, then no more entries will be given. The same way with respect to elements. Then start removing it. So the first person or the first element which is inserted will be the first to come out from which end? Front end. So you have two different ends. That's what it says. Insertion from the rear end. So here it says item is inserted from the rear end and it is removed from the front end. Two different ends we follow for Q. And the two major operation here it is NQ and DQ. So NQ says it is nothing but insertion. NQ means insertion and DQ means we are removing, right? So we are deleting the elements from the front end, means it is DQ. You can just remember this name DD just for blind remembrance. Okay, so it is NQ insertion and DQ it is deletion. So how these elements are arranged, how we can do this insertion operation, deletion operation with respect to this front pointer and rear pointer. What are all the values that we need to follow here? What will be the value if the queue is full? What will be the value if the queue is empty? How about the front pointer values, rear pointer values? Let us understand all these things in the next video. So stay tuned to my channel. So we will be understanding the values of these front and rear and how these data elements are actually represented in the memory. So we will understand the memory representation of queues with the front and rear values. So that's all for today's video. So in the next video, till then, take care. Bye-bye.